Login accepted.
Good morning. Good morning, Devoxx. I hope you've had wonderful 2 days of the conference. I'd like to kick off the third day of the conference with the topic that is very close to my heart, which is immutability. I'm Michał, and let's set the stage by going back to 2001, when Java was in version 1.3. That was even before the current versioning scheme. And we didn't have generics, we didn't have streams, we didn't have concurrency utils. So it was very plain and simple language, but it was getting more and more popular. It was getting popular even around universities. So University of Texas, around the same time, in 2001, tried to change the language, their introductory programming language for students, so the first language that the students learn when they join the university, from Haskell, from functional programming language to Java, exactly the same version 1.3 I just talked about. And one of the former professors, very famous computer scientist, Edgar Dijkstra, heard this rumor about changing the language on his university. He was a professor at the University of Texas, exactly, and he wrote a very short but important letter. It's still floating around the web nowadays. In this letter, Dijkstra said that argued against this change and said that facing students with the novelty of functional programming drives home the message that there is more to programming than they thought. And it is of course about students, and the first programming language, but even us, like majority of programmers nowadays, started imperatively, right? So we hacked around some programs. It was usually using an imperative language. So even for us, there's something to learn from other paradigms too. So we can kind of like see this opposition, which is not truly an opposition, which is more than that. We can learn to be better programmers, but by trying to fetch different ideas from different other paradigms. So we are imperative programmers, so we use like step-by-step statements. We use operational reasoning, which is like, when you debug a program, you just go statement by statement, seeing what's happening in your program, what is the state of this variable or that other, what happened there and what happened here. While in declarative or functional languages, we use more rigorous thinking, like relationships between values. And this is what I want to show you today. And the inspiration here is that we can learn a lot by having some tools, exactly the tools that we use, and we can choose them, right? So for example, many universities switch to Python. What I like to show you is even the smallest possible tool in the language, like a REPL, like JShell, or Scala has a REPL, Python has a REPL. Even this tool has some insider kind of like features that helps us learn something or not be aware of this particular thing. So let me show the example. On the left, you can see a Python REPL, right? And in Python, when I say 2 plus 2, I'll get 4. That's about right. But what happens when I say print 2 plus 2? I get exactly the same 4. There's no difference. Like, okay, firstly, I did 2 plus 2, so it's an operation of 2 values that produces a value. And secondly, I just printed something to the console. But from the user perspective of this tool, there's no difference. And in Scala, when I say 2 plus 2, I'll get an information. This is a new value, auto-generated name res0, but it's an int, and it is 4. While print-lining this is the same calculation, is exactly what we see in Python. So there is a difference between an operational thinking, like what happens, and declarative functional immutable thinking, rigorous one, when there is the relation between values. 2 plus 2 is 4. What is is it. And of course, in Scala, we have, and other programming languages, we have immutability built in. So if we have a list of A and B, it's an immutable value. If you want to create another one, list CD, so a list of 2 strings, and we want to append all things from CD into AB, we'll get a new list, new value. So AB and CD will stay exactly the same. And of course, in Java, we have the same with strings. So if we concat AB, CD to AB, we'll get a new value. Nothing changes, right? So we can kind of like see this from even from the REPL perspective. We can see that there is difference between having a value, relationships between value, and operational thinking. What happens with this area, or in the console, or in the memory? So there is a very subtle but important differences, even in smallest tools, and the tools shape our thinking. So imagine that many universities switch to Python around the same time. So students, new programmers learn to use REPL, learn to use those things. They learn to use like values and operational things. Like there would be the same thing in their heads, because there's no real difference in the tooling. And if there's no difference in the tooling, then the teachers and trainers can't really focus on this difference, because it's very hard to highlight, right? So if we used Python from the beginning, we wouldn't be able to learn those important computer science and programming, software engineering techniques. And that's why, even if we use Python or other imperative languages, we can still kind of like learn functional paradigms and declarative paradigms to be able to get this knowledge, gain this knowledge, understand more about our area, and understand more about what is it and what does it do, reasoning, right? We can learn a lot from here. So, for example, in Java, right, and more modern version than 1.3, we have this ability to do statements, right? So Java is very statement-based. And here we have like 2 lists of integers. Look at the, not the code, because it's very simple, but the flow of the thinking process, right? We first need to create this value, which is, sorry, this is area in address in memory, right? Second one, which is empty, and then we get each x from x's and adds a new result to this result area in memory, and then we just produce something like, I don't know, assert something, again, an operational thing, or print it, or whatever. But it's this kind of flow. While in what is it approach, like functional and declarative, we see that those are just immutable values and the relationships between them, right? So we can change any value. That means that we can just use expressions and entities and think about not what happens, but what they are here in this line of code. They can't change for the same argument, so we can really get more insider and in-depth knowledge about them. So we can even say that it's always, in functional programming, declarative programming, it's always like that. Something comes in, value out, and we can draw those kind of things in all our programs. I will show more complicated examples later on, but the idea is exactly the same. Like, we just pass values around. And we can think rigorously about those values, because one value is created based on other values, and this one is used in other expressions, and so on and so forth. We can kind of focus on different areas of our program. And so more complicated example, so we'll just be leveling up here. So what happens when we run something like that? So we have a TV show, The Wire. There's like 20th anniversary of The Wire, HBO show, and let's imagine we have a string like that, The Wire, and the year it started running, the year it ended running. Like this kind of like very raw approach of string. And now we want to extract, so parse, some information from this string. So we have 2 functions. That doesn't matter what they do, substrings and ifs and all that. Doesn't matter for this discussion. Extract year start extracts the 2002 year. 2008 is extracted by using extract year end. So if we have this properly formatted value, we'll get the values we need. But again, look at the flow. Look that we need to kind of like extract this year into this value, extract this year into this value. What happens when we extract year from Chernobyl? Like what happens when we pass something else? Well, our code blows up because if something happens, then we have this exception. So it's not great, right? For some functional programmers, it's terrible. So following exceptions here is very important in this kind of program flow that you do. So you need to be aware what method will throw an exception, when and why, and so on and so forth. You can't really think rigorously. You can't really have these relationships between values. So machine would do better than us, right? Because this kind of like following the code path is what machine does. So here we would need to kind of like do this try-catch. In order to solve this particular problem, we need to first extract the start year, and if it fails, then extract single year. It's a simple example, but I'm sure you've seen a code like that in your career and your project. So this is very imperative. This is like CPU-like. This is step-by-step statements, right? Thinking. We need to think like a machine in this example here. And in functional programming, we have this option type, right? And it's almost universal in all languages. It has two subtypes. Either it's some or none, but both of them are just option values. So we can use it to our advantage. Instead of throwing an exception, for this simple case, we can just return an option. And when we use this, we can have this one expression that kind of like handles all the things that we just mentioned without having to run our minds around this particular exception, throwing here and there, or trying and catching and seeing what value needs to be passed into what memory area. So this exactly says what we want to do. If extract year start or else extract single year, that captures like this single function and three entities. This single expression captures the relationship between the year value, which is an option as well, and those two functions that return immutable values. So we can think rigorously about it. So immutability against the machine. And we can learn about more techniques in programming by approaching our programs with immutability in mind. So Dijkstra, coming back to Dijkstra, what he said at the end of his letter is that we can learn a lot from other things. We can learn a lot from other people, other paradigms, other projects. So it's not only the violin, so imperative language that we use that shapes the violinist. We are all shaped by the tools we train ourselves to use. So we can train ourselves to use functional programming, immutability. We don't have to think like machines. Plus, because there's like one upside of the whole discussion here. Like 4 days ago, Brian Getz, who is Java language architect at Oracle, wrote a data-oriented programming in Java article. The link is at the bottom. So this is an InfoQ article, and we can see a different approach where Java is going, in what direction. It's like reactive streams, we already have that, but also, sealed classes, pattern matching, all those functional goodies are coming to Java. So if they're coming to Java, that means that those techniques will be available sooner or later, but probably they will, because this is kind of like pattern we've been seeing over the last decade. So this pattern is exactly that, passing immutable values around. We can have this for lists, we can have it for options, but what about other things, more complicated, right? It's like 15 minutes of this talk, and it's all boring. Options, lists, and what not. So let's do something more advanced, but using exactly the same technique. So we talked about strings, lists, options. Now let's talk to the outside world. Let's talk about APIs or databases or something like that. What kind of approach will we take to handle these cases? And we'll do it by showing an example of a very peculiar travel guide. So user can search, like this is the description of this example I'd like to implement using immutability at this talk very, very soon. User can search for an attraction name, an attraction, like tourist attraction, right? And the application will develop needs to find the attraction and the location, like geographic location of this attraction, and then return like at least one movie that is set in this location. So this will be like a travel guide for movie goers. For example, Bridge of Sights, that in the example, the user inputs Bridge of Sights, and the application finds that the Bridge of Sights is located in Venice. And before visiting, we can watch Casino Royale. Some of those scenes were shot in Venice, right? So this kind of like travel guide would like to implement using just immutable values. Let's start with the model. Like 5 immutable value types: location ID, location, attraction. So attraction has a name and is inside a geographic location. That's the first 3 lines of code. That's what they mean. And the movie has a name and some kind of like box office earnings. We can also get that to kind of like sort with the highest earners at the top. And the travel guide, the main protagonist here, attraction has an attraction and a list of movies. Exactly what we wanted to really return, right? A list of movies, at least one movie, that would be fine. Let's start with that. So this is the model. We won't change it. We just use it throughout the example. And we'll use Wikidata. Wikidata, open service. I know, how many of you have used Wikidata? Nobody, really, nobody. Okay, but that's very cool. You can go to this website here, and you can insert the like SQL-looking queries. This is SparkQL language. It doesn't matter here. Exactly the same would happen if you have another like knowledge base. It can be Postgres, it can be Couchbase, it can be anything, right? But the key point here is that we have some service. It's open, we can use it. I hope that the internet works fine. And we will use this query to find the tourist attraction. So exactly, this is the query that finds Bridge of Sights, and you can see at the bottom that when we run it, it will return that Bridge of Sights is in Venice. And of course, there are some identifiers internal to Wikidata which we can use to kind of like identify the resources like Venice or movies. So this is our backend. This is what we will use. And we'll use Apache Gina. It's a free and open source Java framework for building these kind of applications like semantic web and linked data applications. We can use it to connect and do the queries against Wikidata. And more importantly, this is imperative library. So I don't want to kind of like use some very nice functional libraries and just show you that it's possible, because we will probably understand that it is. What I want to show you is that you can use any imperative library and still use it as a functional paradigm in your applications, and that's what I want to show you. That's why Apache Gina, very popular but imperative library or service framework. I don't know. Let's start with Java example. So how would we do this kind of query in Apache Gina in Java, like imperatively? Again, look at the flow, right? We have this value called query. That's fine, that's nice. But then we need to create a connection, API, kind of like imperative, doesn't matter, but we have a connection, we have this execution, and then we have this iterator of query solutions, which is internal, like Apache Gina description of the solutions that are coming in for our query. And then we kind of like go through this iterator, and for each solution, we just print it, right? So free random, this query, as you can see, is limit free. So we can like return free random tourist attractions with this query against Wikidata. We got Yellowstone, Eiffel Tower, Table of Monte. That's how it works imperatively. Now, using the same library, but functionally, like immutable values, we can have a function that takes this string, which is an immutable value as well, and then we return IO of list of query solutions, not just a list of query solutions, but an IO value. So IO is immutable value representing potentially side effectful program that, once executed successfully, will produce a list of query solutions. So this is what this type tells us. So it's an immutable value. So we can create this immutable value by kind of delaying the block of code that we pass. So here we are passing this like connection query and creating the query. So this Apache Gina imperative style, a block of code, exec select at the end. We are putting it into delay. It's not executed. It's just there stored in this value. And this value kind of like describes what will happen when we run it, but it's not executed. So we can then have this new value, solutions program, by running this function. And what will happen when we print this program, solutions program value? So please tell me, who knows? What will happen when I print the solutions program? So with the same query I showed you before, like the 3 tourist attractions that are like randomly queried from Wikidata. Yes, please. Not very close, but not exactly what will happen. It will just print a value, because IO is a value, right? So function is a value as well, so you were very close. And so nothing happens. That's the key point here. We have just a value that describes a program that, when executed, will return a list of query solutions. But we haven't really executed this program yet. It's just a description. And how useful is it? What do you think? Is it or not? We need to run it, right? Yes, we need to run it, but not yet. We can do other things first, before running it. We can do this rigorous thinking exercise that Dijkstra was talking about. So we can work with those values and do the business logic by working with those immutable values. So what we can do, we can map. IO has a map, like list and option and others. It can map things that are inside. So we can transform the result of this call, list of query solutions. We can transform the results that we don't have yet into some other thing, like a list of attractions. Attraction is the model, our internal model, right? So we can have this kind of like approach of using the results without really having them yet in our application, because this is exactly what we need, like relationships between values. So parse attraction is another like function that returns an option, something like extract year start that I showed at the beginning. So we can map the solutions with this parse attraction function, and we'll get another program, attractions program, IO of list of attractions. So a value that describes a program that, when executed, will return a list of attractions. So again, if I print the attractions program, it will just print an IO value. What else is important? The solutions program stays the same because it's an immutable value. So we now have 2 program descriptions. One of them returns a list of query solutions when executed. Second one returns a list of attractions when executed. We can use them whatever and whenever we want them to be used. They represent programs that will be run in the future. I will show you how to run them, of course, but not yet. So what's important here is that, again, we use the same paradigm. Like, we have some values in, values out, even for programs that do side effectful things like API calls. So let's code it. Let's really show the implementation of the travel guide, like real travel guide that will return Casino Royale, hopefully, or some other movie, I don't know, but will be running correctly. Let's see. Let's start by looking at, I will make it bigger. Yeah. So let's reiterate what we've had on the previous slides. So we have this query, and we have the solutions program I showed you. When we print it, it's just IO, and we have this attractions program I showed you, right? So solutions program, when we map it with solutions, we'll get another program with list of attractions. So we can run it later on. We can also do multiple more things with that program. Like, what we can do is we can create a list of programs. What do you think? Maybe first let's start with attraction program, not attractions program, but attraction program. So a program that returns a single attraction, like the best one. not the list, but single attraction. What do you think should happen here? How would I implement such a program? By using the attractions program, the one that we implemented previously. What we should do in order to get a program that returns just a single one if it's found? Yeah. So if we map over the value, we will get like a list here, right? So we need to pass a function from list of attraction to something that we want to be mapped for. And so attractions function, so this is a function that takes attractions and returns attractions. And we have this head option thing, function that returns an option of the head if the list is not empty, right? Sorry, it always returns an option, but it's a sum value if the list is not empty. And that's all. So we have this program. And we can even have more programs like that. I won't bore you with that. But what's important here, we can have like a list of programs. Again, having this attraction program twice, and then by having this list of programs, we have a list of I/O values. Again, nothing is run, nothing is executed, just immutable value, immutable list of I/O programs that will return an attraction. Each of those programs will return an attraction or not. We'll run it very, very soon. So we can also use the sequence function that gets this list of I/Os and returns it as an I/O of list. So we have a list of 2 programs. When we sequence that, we'll have a program that will run those internal programs and return a list of the results. So we can do things like that just by having those immutable values. And we can run them by using this unsafe run sync. So it's very close, but it should be like at the end of your program, right? So you do all the immutable transformations in your like application, and then you just do this once, like unsafe run sync. And if you do unsafe run sync, it will most likely will just return something. Let's see. So we have this. What program would we? We'll run this program. So I/O of list. So 2 queries will be executed. Hopefully, it will run correctly. Let's see. Querying Wikidata. So we are running. We got this first print line, and we got some list of two options. First one is of Eiffel Tower. The second one is Eiffel Tower, so not random, but you see that the query was executed 2 times, and we got something from the Wikidata itself, because as you can see, I'm not kind of like doing any sneaky things here. We're really going into query Wikidata org. There are some API limits. Let's not hit them. For educational purposes, should be fine for us. So yeah, so it did work, right? So we did like a bunch of different operations here, expressions, operations on values, 1 value in, 1 value out, and nothing more. And then we just run it, and that was executed. As I said, at the end of the program. So let's implement the first version of the travel guide finder. I want to kind of like do the final implementation, because that's what we can really do here. It's very, very small for the functionality that is not that small, right? Because it does something. It queries something. We have this data access. Data access is a interface. Find attractions is the function that for a name and some limits, so additional parameterization, right? What I just showed you, those 2 functions just return I/O values. So again, those functions are pure. They get some values in, some values out, and we need another query, so I/O value that represents a list of movies, but the same technique applies. Like we will just query the Wikidata and map the programs inside of immutable values and return it. Nothing is executed, nothing is run. So we'll use this data access, and of course an attraction name that the user provides, and we'll need to return an I/O of travel guide. So the thing that we wanna find. So so what we need to do first is we need to find the attractions with the given name, and we'll get a value that is a I/O of list, right? That should be here. Yeah, I/O of list of attractions. So what we can do next, in order to find the latest attraction, let's just query 1 with limit 1. And here we have this attractions we know that it's maximum 1, so let's just say attractions head option. So now we'll have a program from IO value, a description of a program that returns an option of attraction when it's executed. So then we can map it again, and then we have a maybe attraction, which is an option. And we can say, OK, maybe attraction map again. So here we have an attraction, right? In this mapping value, because we are mapping over option here, we have another attraction. What we can do with that, we can, for example, have a function. We need a function, attraction, and we can, again, query movies about location of this attraction. Location, ID, again, let's just find one movie. And then we can map, because this is, again, an IO value, right? This is immutable value, IO of list of movies, so we can map those movies and create the travel guide with these attraction and movies that we just found. And that's mostly it. It's the application. So just a random, mostly it, I said, because what we get is IO. So what we got is IO of option of IO of travel guide. So, and we can read that. It may be a mouthful, but it is what it is. It's a description of a program that returns another program, maybe, or option. And that program, when executed, will return a travel guide. What we can do is we can kind of like flatten that using the sequence we used, and this will, we need to map this maybe program, that's me, maybe program, and yeah, sequence that. So we are mapping and flattening, and that's it. That's the program that we implemented, and it does what we wanted it to do. Again, very concise, but these are just immutable values in action, value in, value out. We can, of course, refactor that into some more names, more values that are named, but the process is exactly the same. We just need to transform immutable values. So hopefully this is running fine. There is just one formatting here, problem here. So let's just execute this. Version 1 travel guide that we implemented, bridge of sites, unsafe run sync. So this is the only imperative line of code that we are executing. And let's see whether we get Casino Royale or something else, but hopefully it runs fine. So let's run guides, application, compiles. Oh yeah. So we got bridge of sites, Venice. As I told you, the movie is different. Maybe something changed. You can see that box office is pretty big as well. So Spider-Man Far From Home, probably also shot in Venice, hopefully. Wikidata has our backs here. So that's how it works. And we can, of course, do more things. Like, OK, so here's the first version that just queries for one attraction and returns single one with one movie. What we can do is we can have maybe more, maybe not one, but let's have query for 3 attractions, and then not do that head option, and just map over attractions. So that the changes won't be very very big. We'll flat map later. So attractions. So this is a list, right? List of attractions. We can map again this list of attractions into this exactly the same thing. Maybe let's query for more movies, so we have some more things to make our implementation based on. And yeah, we can just use this approach. So we have here some additional list of IO values, right? Additional list of IO values, and we can just so if we have a list of IO values, we can just sequence them, right? So we get an IO value of lists. And sequence. And since we need to kind of use the IOs of IOs, then we just need to flatten them. And what we get, so again, the internals don't really matter because we are programmers. We need to be very careful. We need to be focused and all of that. It's a second nature when you do it for a longer time. But what's important here is that we have this value again, immutable value, that is like IO of option of travel guide. Sorry, it needs to be an option, IO of option of travel guide, but this is an IO of list of travel guides, right? So when you will look at the exactly what's here, it's IO of nothing. Sorry about that, but that's not nothing. But let's say that we need to kind of like create a function like list of attractions that will be returned. We need to return one of those attractions. So, and this is one of the possible implementations. But the second one is that we can have like a real business logic, right? Not IO-based business logic, but some other pure function, like what to do when we have a list of travel guides and we need to return an option of travel guide, like choose the best travel guide there is from the one that we have at hand. So one of the possibilities, so it is a no IO function, right? It's a pure function that just does business logic. What I want to show you is separation of concerns, like travel guide does all those things with IO, does the side effectful things, but we can still kind of like using map, flat map, and other things, use functions that don't do any IOs, and we can be sure by looking at the signature. And no IO, this is just a pure function. We can unit test it, we can property test it, we can do lots of things with that. So this travel guides list is sorted by the size of movies, then reversed, then returns the top one. So right now, we have a business logic for returning the best travel guide, which contains the amount of the travel guide with the most amount, the biggest amount of movies. And we can use it. We can use it here, like map with guide with many movies, and that's it. So we now have a program that runs like 3 attractions, 3 movies for each, and returns the best one. And of course, we can go on and do all those nice tweaks here and there. But the main point here is that we really have this possibility of talking to the outside world, but just transforming values. And what I showed you is really like 99% of use cases in the applications that I've been developing in terms of API calls or database calls. Really, it's just that. Of course, in databases, you have also transactions, but you have values that handle that as well. So don't worry about that. I can show you later or after the talk. Just approach me. I will show you the project I'm currently working on, and this uses this approach in database world as well. So this is what we'd like to do next. Threats, resource safety, and state. This is like the hardest part of this, but the idea is what I want you to take away from this talk, right? The idea that we can use the multi-threading using exactly the same approach. We can use resource safety management using exactly the same approach. You probably can guess that those will be just immutable values describing these things, and you would be right. So for example, let's do it very quickly. Like here, we do for each attraction, we query the Wikidata like in sequence, right? Because that's what flat map and sequence do. What we can do is we can make it concurrent. I'm just copying the previous implementation, and you can see there's just one difference. Instead of sequence, we just do parse sequence. What it does, it returns so if we have a list of programs, that I showed you before, and you sequence them, they will be executed when we execute them at the end of the program. They will be executed in sequence. But if we use parse sequence, we'll use thread pool and just execute them in parallel, like the IOs. Of course, there are some blocking concerns and things like that can also be handled, but that doesn't matter for this particular discussion. So that's it. And we have a program that runs multiple threads. For each attraction, handles the querying of movies in parallel. So that's it. What about other things? Like what we can do, we can solve a problem that we still have here. So when you maybe you notice, maybe not, but we have this connection that we create unsafely. Like what I showed you at the beginning. It just kind of like use Apache Gina to build the connection and open it, right? So this is the connection that we've been using so far in the program here. So that means that we kind of like need to be aware of closing this connection, because if we don't do that, there will be leaks, right? And of course, so this particular thing is very operational, like very imperative. Like we need to create a connection, then do something, and then close the connection. Remember to close the connection. Even if there are errors, even if there are failures, problems, parsing, or anything, like we need to close the connection. Of course, there are some nice solutions to that in the operative world, but what I mean is that we can really do something even nicer, and that is another immutable value. So we can have a connection resource. Connection resource will be of type resource that has two types. One of them is IO that you already know, and the RDF connection. So IO is the side effect, the type that tells us that it will be a side effectful operation because it's opening connection. And the second one is the connection that we are guarding against. And we have this resource make constructor as IO delay that takes two IOs. The first IO, so a description of a program that creates a connection. So we can say IO delay, create connection and safely. Again, this is just a description of a program. Delay just takes the thunk and stores it, doesn't run it. And the second thing is closing the connection. What should happen when the connection should be closed? And that's all. We create a value. So in this case, we have a function from connection into a program that should be run when the connection should be closed. So in our case, we just use the Apache Gina close. Hopefully, this is exactly what I wanted to tell you. Yeah, and that's it. So we have this resource of IO of RDF connection. This is an immutable value that describes a resource that needs to be acquired and released safely when the program ends, no matter what happens. If there are problems with the connection, anything, it will be executed. And this is one value that describes that. So what we can do is we can run a program using, we can use this connection resource. Use is another function that takes a function from connection into the program that should be run when the connection is acquired, and the connection should be released after this program that we passed is executed correctly. So again, we used exactly the same travel guide. So separation of concerns. We are now handling the resource safety concerns outside of the scope of the travel guide. So no try, finally, anything like that, no retries, anything like that doesn't happen inside the travel guide we implemented, because we implemented the travel guide only using the immutable values. And now we are concerned about resource safety, or any other kind of safety that resource can handle, and it's handled, right? It's handled correctly. It will not leak anything. So this program, when executed, will acquire the connection, will run our program, will release the connection no matter what happens, and return the values that the program generated or returned, right? And that's really what there is to it. Nothing more. So we have this notion of type that describes the resource safety. And separation of concerns is important. So if we want to cache the results, that's very important as well. If we want to cache the results, we can have exactly the same approach. I don't want to kind of bore you with the internals, but the idea is what's important, right? Idea is that we can have exactly the same program. This is here. Program with cache that uses the connection resource without changing it. It returns a list of optional travel guides, because we have we have a list of 100 programs, 100 IO values that we parse sequence in order to check whether the caching works, right? Because if we run the same program against Wikidata for breach of sites, we should be getting very similar results, because we are now producing the biggest movie there is, and so the Spider-Man should be at the top all the time. So we can just run the first query and then use the results later on. And when we run this program, hopefully, let's run this program. let's comment out this here. Run program, and I will describe what happens. So ref is exactly the same idea that we have with resource with I/O. Ref is the description of a value that is inside your memory and is mutable value. Okay, so it's a description of mutable value because we need that, right? We need, like, we have multiple threads, multiple things going on in our program. We need mutability, but we don't have to mutate in our programs. We can use the immutable values that describe the mutations. So here we have a ref value, again, inside the I/O type, that creates a memory address with the map, immutable map inside, starting with map empty. And what we can do is we can kind of like flat map that into having this cached value, ref value. And what happens when we get a cached value? We get a program. This will be I/O of a map. So cache.get, the ref value.get, will return a program that, when executed, will return the current value of the mutated memory. The same with update. Update on cache works like exactly the same. It takes a program that will be run when we need to update the mutated value. And as you see, this really works fine. We got like 100 in a few seconds from the same Wikidata address, 100 programs results by using this approach. And again, what's important, this is exactly the same travel guide that we wrote, right? What we changed is this function cached exec query. We had exec query before. Now we have another function that has this separation of concerns in mind. So concern of caching is outside of our program. Nothing about caching here. Nothing about caching here. So we implemented cache on the side. And that's really important because we are doing like immutable value transformations. So let's go back to the presentation. We are wrapping up here. We have immutability, the declarative functional. We are focusing on what is it, what that value represents, how it's created, and not imperatively like operationally debugging the stuff in our program. What happens here, what is sent here, what the value in that memory address is. And of course, this is just an example. We can kind of like use it as an inspiration to get better at what we do imperatively. But there are projects that we're working on that we use this kind of approach rigorously, and it works very fine. So if you still are not convinced about that, please remember that if we go back to 2022, we have Java that is going into this particular direction. Like pattern matching is in Java as well. So we didn't think that would happen like even 10 years ago. So it's really happening. So all the functional goodies that I showed you, they will probably in one form or another will be in Java very, very soon. And of course, there are some other languages like Kotlin, and I think there is a talk in this room later on, like 2 talks from now, about exactly the same techniques I showed you, but in Kotlin. So yeah, something's happening, so please have a look if you're interested. And of course, if you want to learn more about that, I have a book. Sorry for the shameless plug. The example I showed you is a simplified version of the example in the book, later part. We start the book, it's for beginners. This talk is for like more expert programmers, right? But the book is for beginners. We start with strings and just functions on strings. But we end up in chapter 12 using these IOs, resources, and multi-threaded applications and all that. So it's a step-by-step real-world example guide. If you like this kind of spirit of this talk, please have a look at the book. I think it's 40% off right now, so the code won't be really necessary. But have a look. Either way, or if you have a friend that wants to learn about functional programming, also please let them know about the book. And hit me up if you have any questions about the book or the talk. I'm here at the conference until noon, I think. And yeah, grab me here or in the hallways. Thank you very much. I hope you've enjoyed the show. Thank you.